Well, hi everybody, and we're back on this farm radio. This Canadian General Electric Model C57B battery operated radio, commonly called a farm radio. And the thing about this radio is, if you've watched the earlier videos, you know there's no power supply with this radio. It's meant to run on batteries. A low voltage battery to run the 1.5 volt filaments in the tubes, and a 90 volt supply that's to supply the B+. And in the last video I had discovered this curious situation where, as I turned off the power supply, the radio came more to life, and it turned out a 50 volt B+ seems to be a better B+ for the radio, and that's in its current condition. And what we're going to do now is we're going to go ahead and we're going to replace all these paper capacitors in the hopes that that'll bring the radio to life, because it's not working properly. I haven't nailed down the cause. So in the meantime, I might as well replace these capacitors. There's not too many of them in there. So that's what we're going to get busy on, and I'm going to pick the toughest one to start. What I think is the toughest one, that'd be this one down here. And it's tough because it's buried under these wires. And if I could pick it out of there a little bit. Yeah, it's not quite as buried as I thought. These wires, these ones are very, very stiff. I don't want to move them very much. Okay, there he is. Let's get him out of there. There it is. 0.01. And we need fairly long leads to make it between there. Here's a 0.01 here. That'll do the trick. Just trying to pull out the old wire. Ugh. Doesn't want to come, I'll leave it. Yeah. I'm not even sure what I'm grabbing onto there. Okay. You can stay. Change the lighting here a little bit. I'm limited as to what I can do here. Let's bring this other light over. The problem is, when I swing my hands over top of the work, they come between the light and the work, and they just put a shadow on it. So I'm trying to make the lighting work for the camera and for me at the same time. Now, some of you might assume I'm a super expert at doing these things. But it's by virtue of the fact that I'm videotaping it and sticking it on YouTube. No, I wouldn't call myself a super expert. I certainly have enough knowledge to get into trouble doing this, that's for sure. But I'm not a person who knows everything about everything, that's for sure. And that's part of the reason why I put this on YouTube. I think I was explaining this before. I'm hoping those with more experience are going to give me a bit of helpful guidance now and then. Like lots of people, I have no formal training really in doing this repair work. I have formal training in electronics. Certainly not of this vintage though. And even when I went to college, this stuff was old and long passé. This stuff being vacuum tube technology. In fact, I went to college in the late 70s, and the first thing we were told when we started was that transistors are old and they would not be concentrating much on teaching us about transistors. Okay, so there's number one in. Okay, that wasn't so hard, was it? Now, number two. I think this big thing down here. Let's see if we can get the size of that before I go in. And 150 volts. So it's a 10 microfarad capacitor. What's a 10 microfarad capacitor doing? Can that be a bypass on the output? I don't see a cathode resistor on the output tube. Sorry about that. Here's the output tube. I don't see a cathode resistor, so there's no bypass capacitor around it. What's a 10 doing in there? These are all directly heated cathodes, or there's no cathode really. And that's of course because these are very, very low power tubes, and they don't want to throw away the power that you have to throw away to heat a separate cathode. Being a battery operated set, there's no hum problem. No, I'm not spotting the 10. Let's see, it's connected to this coil. It's a coil to ground. C4 with no value written on it. That's not helping. T1. This could easily be T1 here. This could be T1. T2. It's one of these two. Somebody show me a 10. I don't see it anywhere. Okay, we're going to leave that one, I think, because I don't think I have a 10. Maybe I do. Maybe I do. 10 at 150 volts. Let's see, there's a 47 at 450, 47 at 160. And I want a 10. Show me a 10. What's this guy here? That's 1,050. That's a little big. And this guy's going to be a big one. Oops, there goes one out the bag. Oh, 50 volts. What's that one? 47 at 50. That's not going to help me. And this little one here, 1,000 at 25 volts. So I don't have one. It's really close enough to stick in there. Or I'll have to go digging deeper. So we'll skip him for the moment on the assumption that it's good anyway. Let's put the ohm meter on it. See what we see. I can't do too much about it right at the moment. Oh, jeepers. Just about dropped my meter on the floor. I was watching in the camera on the screen to position it where you can see it. Hey, there's a good spot. No, that's not good either. Hey, how about like that? I can't really get at the capacitor. Okay. One lead's grounded, and the other one is coming up here. There it is charging now. Pretty slow. 500K, 600K. Yeah. Well, it's not shorted anyway. We can be sure of that, I think. Okay, so we'll leave that one alone. Let's look at this other big guy over here. I think this too is probably this one here. Maybe on pin number 1, 2, 3, 4, 5, 6, 7, 8, 7. Pin number 7. Let's see if that works. Okay, so pin number 7. No. Pin 7 goes to ground. Oh, it does go to ground. So this capacitor is just using a ground point here. Yeah. The other side of it is going into the switch. No, I'm not spotting it. Let's see if we can read it here. 0.1 millifarad. 0.1. There's a 0.1 here. 124. Now, is that going to be long enough? Yeah, if I leave the leads, it'll do it. So we'll cut them out. It's also awkward doing this work with the camera, because the camera is often in space where you want to put your hands or arms or whatever. I have to kind of work around the camera a bit, so occasionally what you see doesn't reveal how awkward it is for me to put my hands into those positions. I mean, it's not terribly awkward, but it's not the same as not having a camera going. And another important topic, and that's getting shocks. As you would have seen in some of my previous videos, I got a couple of shocks off a record player, and they were shocks through the grounding capacitor in the player, so they were quite mild, but still disturbing. Not something you really want. So that's resulted in a reopening the discussion about using a isolation transformer to supply the power to things I'm working on. Because the isolation transformer will eliminate the possibility of a conducting electricity from the thing I'm working on to the power system neutral, something like that. And I have it hooked up here again, and once again I'm looking at the problem with my isolation transformer. It steps up the voltage. The voltage is already high at my house, but 123. I think, I was just reading up on this. You know, I worked for over 25 years at a power distribution company, a big one. You'd think I'd know this stuff off by heart, but I don't. The standard voltage, as I understood it, was 115 plus or minus, so you can go 110 to 120. Just reading up on it, it sounds more like it's 120 nominally, and typically 118, 119. But it can go as high as 125, or down as low as 115. That's a little higher than what I expected. And I throw in my, I'll show you what happens here. Okay, so that's my voltmeter, line voltmeter. And I'll just turn the voltage on. You'll see what it goes up to. Now, it jumps a little high at first. 130. It'll relax a bit. I'm not quite sure what it is. Something to do with this meter. So it's going to go back to about 128 or something in that range. The meter's quite accurate. Whoops, I flipped it off by accident. The meter's quite accurate. So that voltage is definitely close to 130. And that concerns me a bit. That's pretty high. I would rather it was 110, frankly. Not 130. 130. So I'm hesitant to use it again. Oops. Because of the extra voltage. I suppose what I'm doing is I'm trading off my safety for the safety of the equipment I'm working on, and maybe that's not a very good trade. And somebody can easily argue, look, if the stuff can't take 130, that's a problem in itself, and maybe you want to put the boots to it a little bit when you're doing this kind of work, so you're actually straining the equipment just a little bit further than it will be in normal service. So there are some arguments for going forward with 130 volts. Okay, let's pick another capacitor here. Well, that's 2 in this video. Okay, I'm going to do 2 at a time, so I'm going to stop and start the video again. We'll do them 2 at a time in the video.